Hi everyone, this is coming to you from Education for All. We are looking at partial fraction decomposition. We solved two problems already using two different methods, two different approaches. So we now want to look at partial fractions, how you can be able to identify them, and then what will be the likely partial decomposition format for that partial fraction. When we looked at this problem here, 3x plus 5 divided by 2x squared minus 5x plus 3, on the denominator here we have a quadratic equation which we factorized. We got 2x minus 3 by x minus 1. So in fact, what this equation is, we look at it, it can be written in this format. This is a constant. We give them unknowns p, q, and we have our x. This is 3x. This p now is 3, q is 5, if you look at this one. When we decompose this partial fraction, we arrive at this equation here. This was the equation we arrived at. So if you are given a partial fraction and you're asked to decompose it, you try to bring it in a situation wherein you are able to factorize the denominator. So once the denominator is being factorized, then you can be able to work out what the likely result of that partial fraction would be. That is what we are going to look at here. The method of solving partial fractions vary from problem to problem, could be different, but the method of solving them is almost the same. Once you are able to recognize the category of which that partial fraction falls into, the method of solving them is either equating the coefficients or elimination, what we did in our second problem. So now, if your partial fraction looks like this, then the partial fraction form will take this format: ax minus b plus bx minus b, ax minus a plus bx minus a. Then you can use your method of equating coefficients or even simultaneous equation, elimination. Then you find your values of a and b. Then you decompose the problem. But what if you are given a problem like this: px plus q, p of x plus q all over x minus I squared. Here you have squared here, x minus a. Then how is your partial fraction form going to look like? In this case, what you get, you will get a all over x minus I, small letter, plus b all over x minus b squared. This is what you get. When you decompose this, you will get this way. Then you will solve for a and b. This just happens to be like this. This is what you get. You have x squared here. So first you will have x minus a, then it will repeat x minus a squared. Sorry, it's a here, not b. X minus a, then x minus a squared. That's our second case. Third case, suppose you have now a quadratic at the top. You have a quadratic here. You have px squared plus qx plus r all over x minus a, x minus b, x minus c. How would it look like in the partial fraction form? What would you get? Again, this is just like our first case. You will get a all over x minus a plus b all over x minus b plus c all over x minus c. You always try to look at, in most cases, that the denominator. Have to look at the denominator. So now, if you have something like this, px squared plus qx plus r, and x minus a into x squared plus bx plus c plus dx plus c. So now you have a quadratic equation at the top, and you have a quadratic equation multiplied by some other function at the bottom. So what did you get? Dx plus c. In this case, you will have I all over x minus a, this one, plus, since this is a quadratic, this is a quadratic, because the thing about partial differential equation, about partial fraction decomposition is the denominator must always be greater than the numerator. I mean, the exponents here, x squared, should not be greater, should not be less than what you have. Here the maximum is x. Here, you know, if you multiply this out, the maximum will give you 3x cubed. X cubed. They almost always have to be proper fractions to say. So this now will give you bx plus c, bx plus c all over, because of this, x squared plus bx plus c. If your function looks like that, here, this is what you get. Bx plus c. Once you are able to identify this relationship between them, the rest is just the same methods we have used previously to solve problems. Just to be able to recognize if you have a problem given to you in this format. For example, now I'm saying like here 2x squared plus 3x plus 1 all over x minus 2 x squared plus 2x plus 1. So they ask you to decompose a problem like this. We are looking at this one here. This is what I've just tried to replicate. So now you should know this problem is going to take this format. It's going to take this format. Going to take this format. So that's all I have for you. Thank you for watching. Bye bye. Complete partial fraction decomposition. Thank you.